All right, let's dive into something I call the art of knowing. I'm not talking about guessing or hoping, but truly, deeply knowing that your code does exactly what you think it does. We're going to talk all about Python testing and how it can take you from that feeling of development anxiety to just rock-solid confidence. So let's just start with the most basic question of all. You've written this awesome piece of code. It runs, no errors. Great. But how do you know it really works? I mean, under all the weird conditions? And what about after you make a change next week or next month? This is the core problem that a really solid testing strategy is designed to solve.
So here's our game plan for today. First, we'll tackle the big why. Why even bother testing? Then, we'll dissect what a perfect test looks like. We're going to build out a strategy with something called the test pyramid. Explore a really cool test-first mindset. Figure out how to test smarter, not harder. And finally, talk about why good tests are like your professional signature on your work.
First things first, why even do this? Well, it's all about making a fundamental shift, moving away from that nagging anxiety of, I hope this works, to the pure confidence of, I know this works. You know, this is especially critical in a language like Python. See, with languages like C++ or Java, the computer checks for a ton of errors before you can even run the program. It's called compile time. But Python's different. It's dynamic, which means it kind of figures things out on the fly as the code is running. That flexibility is amazing. It's why we love Python. But it also means that our automated tests become our absolute first line of defense against bugs.
I love this quote from the legendary Kent Beck. Software features that can't be demonstrated by automated tests simply don't exist. Just let that sink in for a second. Your test is the proof. It's the tangible, repeatable demonstration that your feature is real and that it's reliable. Without that test, well, it's just a bunch of code you hope works.
And look, testing isn't just about finding bugs. It serves at least 4 really crucial purposes. Number 1, obviously, is to make sure your code works right now. But number 2 is to make sure it keeps working, acting like a safety net when you make changes later. 3, it actually confirms you understood the requirements in the first place. And 4, and this is a big one, writing tests naturally pushes you to design cleaner, better, more maintainable code from the start.
Okay, so we've got the why down. Now let's get into the how. What's cool is that pretty much every great test follows the same simple 4-step pattern.
The best way to think about it is like setting up a line of dominoes. The first step, arrange, is where you carefully line up all the pieces. You create your objects, you set up your mock data, everything's ready. Then comes the act. This is the one single poke that starts the chain reaction. You call your function, you hit your endpoint. Next, you assert. This is where you look at the result. Did all the dominoes fall down exactly like you planned? Is the output what you expected? And finally, you clean up, which is just putting everything back so the next test has a clean slate. Arrange, act, assert, clean up. Simple.
Okay, so that's one test. But a real-world professional testing strategy needs different kinds of tests that all work together. And that's where we get the idea of the test pyramid.
At the very bottom of the pyramid, the foundation for everything else, we have unit tests. These are the bedrock. They're small, they're super fast, and they focus on just one tiny piece of code at a time, a single function, a single method, making sure it does its one job perfectly all by itself.
Moving one level up the pyramid, we get to integration tests. This is where we start connecting the dots. We've already confirmed our little units work in isolation, right? Now we need to see if they can play nicely together. Do these different pieces communicate correctly when we combine them? That's what integration tests are for.
So the key takeaway here is the shape of the pyramid. It's not a square, it's a pyramid for a reason. You want a really wide, solid base of tons of fast unit tests. Then, as you move up, you have fewer and, slightly slower integration tests. This structure gives you the absolute best bang for your buck. Maximum confidence, minimum test runtime. All right, let's talk about a shift in mindset that can honestly change the way you code. What if, instead of writing your code and then figuring out how to test it, you flipped that completely on its head? This is the core idea of test-driven development, or TDD, and it feels like you're creating and solving your own little puzzles. It starts with a step that sounds completely backward at first. You write a test for code that doesn't even exist. You write a test that you know is going to fail because you haven't written the function or the class yet. You're defining the goal before you even start the journey.
Now your mission is crystal clear. You don't have to think about the grand architecture or all the edge cases. Your only job is to write the absolute simplest, most minimal code you can think of to make that one failing test turn green. That's it. And just like that, you've done it. You created the puzzle with your test, and you solved it with your code. It's this really tight, satisfying loop that keeps you incredibly focused and produces really clean, purposeful code.
So why do this? Well, there are two huge wins here. First, it guarantees your tests actually get written. There's no more saying, oh, I'll write the tests later, because it's the first thing you do. And second, it forces you to think about how your code will actually be used from the very beginning, which almost always leads to a better, cleaner design.
Okay, having a lot of tests is great, but being smart about what you test, that's even better. It's not about quantity, it's about quality. So let's talk about designing test cases that give you maximum confidence for the least amount of effort.
Let me give you a classic example. Imagine you have an input field, and it only accepts whole numbers between 1 and 1,000. How do you get confident that it works? Surely you're not going to write 1,000 different tests for every single number, right? There has to be a smarter way.
And there is. It's a clever technique called boundary value analysis. The whole idea is that bugs, well, they love to hang out at the edges, at the boundaries of your logic. So instead of testing every number, you just focus on those critical points. You test the lowest valid number, 1. You test the highest valid number, 1,000. Then you test what happens right outside those boundaries. What about 0? And what about 1,001? And with just those 4 simple tests, you've intelligently covered the most likely places for things to go wrong. That's testing smarter.
So let's bring this all home. Writing tests, it's more than just another technical task on a checklist. It's a statement. It's a statement about the quality of your work and your professionalism. In a way, it's your code's signature.
Think about it. When you deliver code that has a really solid, comprehensive test suite, you're not just saying, here's the feature. You're saying, I've not only built this, but I've carefully considered how it might fail. I stand by its quality, and here's the proof. It's a gift to your teammates, and honestly, it's a gift to your future self.
So as we wrap this up, I want to leave you with this question. Don't just think about testing the code you've already written. Think about what you're going to build next. What's the first puzzle you're going to create for yourself? What's the first test you're going to write before you even have the code? Give it a try.